Hello, welcome everyone to this edition of Window.ai Presents. Today I've got my colleague Enrico Rotundo to come and talk about a project that we've been working for a couple of months now, or a few months. Actually, no, a bit more than a few months, probably nearly a year now, actually. We've been collaborating with some really great people at Protocol Labs on a project called Bacalhau. And Enrico's going to dig into the details of this in just a moment. But as you know, Window.ai are experts in AI development, both on the application side and the product side. And this is intended to be a decentralized compute network to enable large-scale distributed data engineering type workloads. Today's talk is all about how Enrico developed is working on developing a DAG type orchestrator for Bacalhau. And without further ado, I'll pass it over to him. Hi, Enrico.
Hello, everyone. Thank you, Phil, for the nice introduction. Yes, so today we're talking about DAGs. What does acronym mean? We'll see in a minute. Let me just start. Yes. So quickly, so the talk is divided into sort of blocks. So first, I will just describe a little bit what a DAG is and what you needed. I'll touch upon what the Bacalhau project is and show you a demo of how we're implementing DAGs in Bacalhau. This webinar is given from the sort of platform engineering perspective, and it's centered around machine learning use cases. We potentially can apply to data engineering in general. So let's consider the word of Alice for now. She's a machine learning engineer. And she loves doing machine learning, of course. There's a number of tasks she goes through in their daily job, and these often involve submitting computation to some other some systems such as a cloud provider, or maybe a nice Python script run on a GPU machine, or maybe they run on a university on-prem cluster. And by the way, there is a new project called Bacalhau, which is also very helpful in this case. It's in GitHub, but we'll talk about that in a minute. What matters is that in a normal scenario, like she would go through this iterative process of writing say machine learning in a training job and submitting that to an external platform, and then maybe wait a few minutes, if not hours, she'll go get a coffee and get results, and maybe realize that at that point that something went wrong with the job and has to resubmit it, maybe adjust the job specification and submit it again. So as she goes through this process, this is going to be very painful. DAGs here come to help. So what is a DAG? So DAG is an acronym for direct acyclic graph. I'll show you an example in the next slide. But I'll use the term pipeline is sort of interchangeable. And in brief, these are scenarios where you want to say chain multiple jobs, one after the other, or have more complex workloads where you fan in and fan out in a sort of a MapReduce style. Or connect to external triggers, maybe an insert to a database or to a data bucket will trigger a computation, and schedule jobs based on calendar and so on and so on. So there is So if you want to have all that, there is a suddenly need to orchestrate all these operations, and we see there is a lot of demand for this stuff out there. And we also have, so in the Bacalhau project, we have also computational scientists asking specifically to add in DAGs to the Bacalhau project. And this is how it's really a production grade DAG looks like. This is even probably even a bit small, but let's say, so this kind of tries to depict a possible flow that occurs when, say, user makes a reservation on some sort of travel platform. And this will trigger a whole chain of computations, such as maybe net promoter score computation, all the way down to the sending of the final confirmation email. And so the concept here is that essentially complex workloads require pipelines. So what I argue is that, like, complex production scenarios such as this one, but also sort of mid-level complexity scenarios also benefit a lot from having pipelines, such as the one that I described earlier with Alice. So there is a little bit of a joke. This is just an insider joke taken from Snatch, a nice movie. They talk about DAGs, not really this kind of DAGs. Go watch the movie if you wish. Really good. But let's take a look at the pipelines, orchestrator scenarios that are available on the market, open source mainly. And there's really a lot of options out there. And by the way, maybe all this landscape kind of covers a good chunk of these players, but it's also good to mention that they're also positioned at different in different areas of the market, maybe more machine learning oriented, more sort of low level data engineering. But one that really stands out is Apache Airflow. And why? Because that is essentially Python, and is so it's very, very ML practitioner friendly. It is extensible through operators, and I'll show the details in the demo. And it also has a vibrant GitHub community. It's really, really, it's much bigger than most competitors. The industry has seen a spike in interest on this tool. And essentially, what we are aiming for in the Bacalhau project is to allow the users to run Airflow DAGs, and possibly convert any containerizable workload and orchestrate that through Airflow. So what is Bacalhau? Finally, Bacalhau, as Phil introduced earlier, it is a distributed, decentralized, it's a public/transparent compute platform. And it's centered around Docker workloads. It also runs WASM, which is a WebAssembly type of computation. We're not going into the details of that, but essentially is a platform that implements compute over data. And that's the acronym. Its acronym is COD, which is the Portuguese word for salted. So Bacalhau is the Portuguese word for salted codfish. So on this tool, the researcher can submit a Docker job to the network, and some time later, she will have the results back. This is all basically, by the way, this is for free. Go check it out. You can use it today if you wish. And yes, we're adding pipelines to Bacalhau. And so this effort aims at essentially expanding the capabilities of the tool and allow users just to run more complex workloads. And yes, we have operators for Bacalhau. So operator or provider is sort of the Airflow extensible component that you want to write in case you're developing a platform such as Bacalhau and you want to use Airflow and your platform together and let them communicate. This is so this slide just shows a demo repository. You go check it out, and please leave comments and feedbacks as you go along, please. This is what I'm gonna show also in a minute. So we're stepping towards the demo. I would just like to quickly talk about what Bacalhau can do for you. It can run virtually any algorithm, really. As long as you can Dockerize it or run it as a WASM program. Bacalhau can do that for you. And the demo I'm going to show is an image processing workload that uses two interesting algorithms. Here's just a brief introduction. So seam carving is actually non-machine learning, but it's an interesting algorithm that can detect seams that are these sort of tiny lines that aim at compressing an image in terms of number of pixels by removing seams that are semantically not relevant to the image. Essentially, it sort of detects what really matters on a picture, which is amazing. And then we also have deep learning powered object detection. So this is an algorithm that is fed an image and can draw bounding boxes around objects that it detects, and will also spit out a label naming these objects, such as, hey, here is a chair, there is a laptop, and so on. So let's say you want, as in Alice, you want to just chain these two algorithms together and submit the workload to a Bacalhau or some other third-party cluster. And you do that without pipelines, without DAGs. So this is going to be painful because you'll have to first submit your sort of seam carving compression job, then wait a little bit, maybe save that intermediate result to disk and double check it, submit your object detection, then wait again, and then save to disk. And this is going to be boring, probably not very productive. So let's imagine, even for bigger DAGs, this can be a real nightmare. So with DAGs, instead, you can code a DAG. We'll see an example later, and just submit that to the Bacalhau network and have it computed in one go. And yes, so I'm going to show you how this looks like. And
all right, we're ready for video magic.
Yes.
Okay. All right. There you go.
Thanks, Phil. So, as I said, in Airflow, you use Python to code your DAG. So after importing, just your Airflow, the Airflow library and the Bacalhau operators that I posted on GitHub, you also want to create a Python context manager called DAG. That it's named after the DAG you want to create, and then you start populating this context with your operator objects. So the first one corresponds to the seam carving algorithm, and the second one is the deep learning object detection. But essentially, what you need to know is you just import an operator and give it an ID and point it to a path where your WASM program, in this case, sits, and instruct it on where the endpoint is, and give it some input. Now, so this input, this is an IPFS data ID that points to an image that I uploaded before this demo to the IPFS storage system. Similarly, the object detection, which is a Docker, this case, workload. The previous one wasn't. Let's not go into the details, but for the Docker workload, you also give it an ID, and you point to the Docker image this time. We're all familiar with this syntax. Give it a command. Internally, it's going to run Python, detect.py, and we point it to a folder where the YOLO object detection weights live, and this is this also is connected to the input volumes that we're passing to this to this step again. So this is called CID. Again, points to a resource that will provide us, which is going to be mounted under /datasets, that will provide us with the neural network weights. We'll see how to put together, these steps in a moment. But how do we let them communicate and have essentially the inputs of the second step filled in with the output of the first step? So we do it with this. The Airflow syntax is based on XCOM, which is essentially it's a key value store that allows you to just point to a task ID. So in this case, just the one above, and specify a key. And these will this will make sure that the output of these job here will be passed along as an input to the object detection. So there's also, if you remember, like the DAG preview that I show you, there's also a step where you want to download. You also want to download intermediate and final results on your local disk. And in Bacalhau, we call this it's a get operation. There's also an operator for these, of course. And the way you use it is you just instruct it to pull the output of a specific job ID of a Bacalhau job ID, and in this case, this is going to pull the WASM. Which is basically the seam carving output and put it on a local directory, and this one is also going to get the object detection outputs. Now we instantiated all of these objects. How do we put them together into DAG? Airflow has a syntax that we see at the bottom of the screen, where you can essentially tell it to run WASM first and then object detection operator second, but also you want to run the get WASM data to local disk after WASM operator has been completed, and same holds with the object detection. So in this, I'm using WASM to refer to the SIM carving operator. Basically, WASM is the runtime that runs the SIM carving algorithm. So once you submit this as a Python script, and after that we can take a look at the Airflow web interface, and we'll see that it properly accepted this DAG, and it's currently running. The darker in solid gray color means that step has been completed, and there's still something running, which is the second get job data to local disk. Very soon, so this runs in say like should be a minute and something, under 2 minutes. And we see that once that's completed, we can just double check on our local file system under the in this case it's stored under the temp folder. We can look at the intermediate results. So this was the input image. Sorry, let me go back for a second. So I've used this Lisbon tram image as an input to the SIM carving algorithm. This is the SIM carving mask that the algorithm detected. The shrunk.png basically it's like the narrower version of that image, where the red seems to have been removed. And there you go. We have also the object detection output on the shrunk SIM carved image as well. Of course, it detects a train, arguably trams or trains. Number of persons, and this is it really. So just to recap, this was to show how to just simply chain together a few jobs and submit that in one command, and all that is nicely coded in Python, language that almost any machine learning practitioner knows. And that's the end of the demo.
Awesome. Thanks, Enrico. It's great. I think I had a couple of questions. So just before I start, if anybody who's watching has any questions, then the best way to do that is to comment on the channel that you're watching this on. So LinkedIn comments, YouTube comments, whatever. It should pop up here for us to see. Sorry for not mentioning that at the start. I think from my perspective, I think there's a couple of things I think you should maybe highlight. One is, could you just bring up the link to the website again so people can check out I'll just show that. There you go. I'll bring that back up. Yeah, there you go. Fantastic. So there's the link to that. That's great. The other thing was I think what's maybe not entirely clear is the role that IPFS plays within this setup. Could you comment on the Well, I guess firstly, the pros and cons of using IPFS. Like, what are the good things that come from it, but what are the difficulties that people might face when using it?
Yeah, so IPFS stands for Interplanetary File System, which is a network of storage servers that that provide you with storage essentially. And the way it works is by referencing to data as sort of a content. It uses content address, right? Data. So these CADs that I showed are basically hashes of the data store on these data buckets. And Bacalhau is designed to work nicely with IPFS storage layer. And there's some challenges when it comes to having such a large distributed storage system, which is decentralized. So any party can really spin up their server and start sharing data. Is it essentially is is availability of the data, because it may happen that you have some certain nodes are down, or there's some so the scale of this network is so huge that there may be latency problems as well. So you don't want to use it for real time, data processing pipelines. So it works very well for you can store large data sets on IPFS. Just be aware there may be some latencies involved, and data may temporarily not be available at times. I would say these are the main challenges.
Yeah, okay. I think the one thing that I didn't fully appreciate when I started doing this was the fact that you need to do something called pin. You need to pin data to IPFS via a third party, via an external provider, and they basically give you an SLA to say that your data is going to be available over the IPFS protocol within these bounds. So you need to do that. And another thing I think is worth pointing out is at the moment, Bacalhau is working in a fully public mode. So it uses the public IPFS network, and the executors are considered to be public. So only public data in Bacalhau at the moment. I think, okay, great. So one final question was, what are the plans for the future with regards to DAGs and Bacalhau?
Yeah, well, I'm glad you're asking that question. So the demo that I showed is the very early stage DAGs that we have right now. I mean, I didn't mention it in the demo, but in that case, it was running Airflow locally, which is not going to be the case in the future for Bacalhau. So the plan is to first, make the open source Airflow operators stable, and also allow users to to not need to spin up their Airflow instance, and the Bacalhau network will give you one. We'll make sure that that an Airflow instance is provisioned for you automatically. And last but not least, there will be data lineage included, which is a great feature that allows you to track the provenance of any data set and any artifact really your pipelines generate. This means that, say, when I show the final, like the tram output image with the bounding boxes, often, when you work on, in machine learning contexts, you have the need to step back and so go back into go upstream into your number of Python script runs and to figure out what input data set your colleague used a few months back, and that's a painful process. And with Lineage, we'll empower all these Bacalhau users to inspect data provenance in one click through a web UI, and this is going to be embedded in the Airflow in pipeline. So the final user will do nothing; will just get these for free.
Oh, cool. Okay, yeah, that's really great. So we haven't had any comments, but if anybody does have any questions, then feel free to fire us an email. Visit window.ai to get details, or you can reach out to Enrico directly. But yeah, apart from that, I'd just like to thank you, Enrico, for a great presentation. Thank you for doing this today, and I've really enjoyed it. So yeah, thanks a lot, and we'll all see you next time. Great, thanks. Bye-bye.
Bye-bye, thanks.